This is the first of 3 videos about simple statistics. We'll have measures of center, measures of variation, and measures of relative standing. Measures of center are ways to say where the middle of a set of data is. An average person would say average, but in statistics we want to be more specific, so we have mean, median, and mode as our 3 options for telling people where the center of a set of data is. The one that's most common that we'll use the most is the mean. We'll be using the mean in lots of statistical tests later in the semester. The mean is what people most commonly mean when they say the word average. So we're going to add up all the data values and divide by how many we have. So if we take a look at the equation, the mean equals the sum of x, so the sum of all the data values, divided by n, which is your sample size. So sum of all values divided by the number of values you have. And we have the term x bar, an x with a line over the top, which would be for a mean of a sample. And we have the Greek symbol mu when you're talking about the mean of a population. Okay. So typically in this class we'll be talking about means of samples, so we're going to use the symbol x bar. But if you ever do see the symbol mu, keep in mind that we're talking about the mean of a population. An advantage of using the mean as your measure of center is that if you take lots and lots of samples and you're calculating lots and lots of means, if it's all from the same population, they should be fairly consistent with each other. One of the disadvantages of using a mean is that if you have an outlier or an abnormal value, something that's far away from the other values, it can really affect the mean. We'll talk about that at the end of this video. The second measure of center is called the median, and that's just the middle value of a data set by counting. So half of the values would be above the median and half of the values would be below the median. And in order to figure out the median, you need to put your list of data in order and then count. So if our number of values in the data set is odd, then the median is going to be our middle number. So let's say I have a data set that looks like this. Okay. There's only 3 here, so the median has to be the middle one. So the median would be 4. If you have an even number of values, so let's say I had 1, 4, 7, and 8. If you have, again, an even number of values, you have to find the middle of the middle 2 values. So you'd take the mean of those 2. So we'd have 4 plus 7 divided by 2. So our median in this case would be 5.5. Okay. So again, put your numbers in order from smallest to largest and then count and find the middle that way. The last measure of center is the mode. The mode is simply the most common number. So if, for example, in these 2 little data sets that I drew here, 147, 1478, there is no mode in those 2 data sets because all the values occur equally. They each occur one time. There may be cases where your data set is bimodal, which means 2 of the values occur with the same frequency, or multimodal, which means 3 or more. So of these 3, mode is typically the least reliable for calculating or reporting what the center is of a set of data. So let's go down a little bit and look at an example. And we have a data set here. We're going to calculate the mean, median, and mode for this data set. So for the mean, again, the mean is the sum of x divided by n. So again, the sum of x is just all of your values added together. So this might take a minute, and this is one of those advantages of watching a video where you can fast forward a little bit while I write down numbers. So feel free to do so. So there's all our numbers, all of our x's adding together. And we're going to divide all that after we add it together by n, which is the total number of values in the data set. And if you were to count them, you'd see that there are 18 values. So n, or sample size, is 18. So then we could add all those numbers together. We would get 34. And we're going to divide by 18. And that calculation leads to 1.888 repeating. And we need a label. So you'll see that the weight change from the data set is in kilograms. So we want to label our mean also in kilograms. So that is our answer for the mean. For the median, remember we needed to put the numbers in order from smallest to largest and then count. Keep in mind there are negative numbers in this data set, and that's what we're going to start with. So the biggest negative number goes first, and we go up from there. And again, feel free to fast forward until I get to the end of this list. Only 2 zeros. So there we are. That's the end of the list. And we know there's 18 values. So 9 is half of 18. So if we get to number 9, it should be right after number 9 will be halfway. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And our halfway point is going to be right here. And then you can see there's 9 values on the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is our middle. And since our number of values is even, we need to find the mean of the two middle values. And we get 1.5, and again we need a label, kilograms, and there's our median. Okay. Now you'll notice that the mean that we calculated before and the median that we just did are different from each other, and we're going to talk a little bit about which one you should report or which is more reliable in just a second. So our last measure of center is mode. And if you take a look at the ordered list that we used for the median, you'll see there are 4 values of -2, and there are no other numbers that have any more than that in the list. So -2 is our most common number. And again, kilograms. So that is our mode. And again, that's a very different number than either the mean or the median, and we'll talk about which we should use later on. So those are our 3 measures of center. Now, we probably don't want to spend a lot of time doing all these calculations by hand like this. So let me show you how to do this on your calculator. So here's the TI-83, and the way that we're going to enter the data into here is going to be in the stat menu. So the stat menu is up near the top in the middle. Okay, here we go. So our stat menu gives us 3 options: edit, calc, and tests. And in order to put in a list, we need to be in edit mode. I'm going to push enter. And here's places where we can put in lists. They're labeled L1, L2, L3, and you can arrow over, and there should be 4, 5, and 6 in your calculator as well. Typically, if you just use list 1, that'll be easier for you in the long run, but as long as you keep track of what list you're using, you can use any of them and then store data for long periods of time. So what I'm going to do is enter this list of data. So we had 11, and then hit enter, 3, 0, and so on. Oops. And you'll notice the last number that I put in, this number 2, it says L1 and then 18 in parentheses. So that indicates that's the 18th number, and that's something you can check. You can check to make sure that the number of items in your list is the number of items that it says you put in a list in your calculator. If that were to say L1 17, that means I would have missed one, and I could go back and double check that. So we have all the numbers in a list, and then we want to tell a calculator to do some calculations called one variable statistics. So I'm going to go back to the stat menu, and your list will automatically save. You don't have to do anything special with that. So you can just push stat again, and now we want to calculate something. So I'm going to arrow over to calculate, and the very first option is one variable stats. So I'm going to select that one. Okay. Now the list that I put in was in list 1, and that's the default. So technically I would not have to do this next step, but if you used a different list, you would need to tell your calculator which list you used. So in order to do that, you can see that above the numbers 1 through 6, you have yellow numbers L1 through L6. So you just push the second button, and then number 1 for list 1, and hit enter. And there are our calculations. So here's the mean. X bar is the sample mean, and you can see it's 1.88, repeating just like we calculated by hand. The other things that your calculator will tell you is the sum of x, so all the values added together. Sum of x squared, which is something that gets put into different statistical tests that you might need later. Sx is the sample standard deviation of x, and this little symbol here is sigma x, which is the population standard deviation of x, and we're going to distinguish between those two a little bit later on in a different video. So S is sample standard deviation and sigma is population standard deviation. It gives you the sample size n, there are 18 values, and if you arrow down, it gives you what's called a 5-number summary, which you'd find in the measures of relative standing video. So min x is the smallest number, minimum, Q1 the first quartile, median is the exact middle, and you can see that value 1.5 is the same as what we calculated before. Q3 is the third quartile or 75th percentile, and max is the greatest value. So that is your calculator. Again, it doesn't give you mode, but that's something that's easy to pick out. But the mean and median are both there, and they matched what we just did. So let's move on. Alright, so the next page in our notes, and let me just zoom in on this a little bit. We're going to calculate a mean from a frequency distribution. So we learned how to make frequency distributions earlier. And now we're going to see if we can calculate the mean if all we have is a frequency distribution and we did not have the actual list of data that the frequency distribution came from. So we are looking for the mean. There's my pen. Okay. So we have, let me just fill in this equation. The software doesn't like to get all the little symbols. So fill this in. So the sample mean, or x bar, is the sum of each frequency times the x, which is going to be a midpoint, and we're going to divide that by the sum of the frequencies. So in this case, x is midpoint and f is frequency. So if we go down here to our frequency distribution, I'm just going to put an x here over the midpoint, and I'm going to put an f over here by the frequency so we can keep track of which is which. And what we're going to do is, again, the sum of all the frequencies times x. We're going to do that part first. So the first row across, the frequency is 5, and the midpoint is 47. Second one, 7 times 52. 2 times 57. We have 4, 62, 1, 67, 2 and 72, and 8, 77. And we're going to add all those together after we multiply. So we have 235, 364, 114, 248, 67, 144, and 616. And add all those together, and that gives us 1788. Okay. So that's going to be the top part of our equation. So then we need the bottom part, the sum of the frequencies. And again, the frequencies are just your tallies. So 5, 7, 2, 4, 1, 2, 8. Add all those together. We get 29. And if we fit that into our equation, we'll put it down here. So we're going to take the sum of the frequencies times the midpoints and divide it by the sum of the frequencies. And we get a value of 61.66 approximately. So we can ask ourselves, does that number make sense? Okay. Let's put a label on it first. So this is a distribution of test scores, which would be probably in points. So I'm going to say our mean is 61.66 points. So does that match our distribution? And if you look at where 61.66 would fall, it would be in this middle category. And that makes sense because it looks like there's, about equal numbers kind of on either side of that. So yes, it makes sense. We've checked our answer and we can move on. The second example on this page is a weighted average. I'm not going to go through all the details. I'll just show you how it's done. This is an example using grade point average, which is a very common use of a weighted mean. So again, let's fill in the equation. W is the weight of each value. And in this case, in GPA, the weight of a grade would be equivalent to the credits, or number of credits a class is. So I'm going to put W over credit hours. X is the value, and that would be the grade points. And grade points correspond to the grade that you earned in a class. So grade points times credit hours would be W times X. So I'll put that above that column. Right, they have some sums already figured out down here. So this sum of 17 is the sum of W. And down here, this sum of 54 is the sum of W times X. Okay. So a lot of the math is already done for us here. And the equation is the sum of W times X divided by the sum of W. So we have sum of W times X divided by the sum of W equals the weighted mean. So the weighted GPA is the mean in that calculation. And that is a weighted mean. Again, each value has a different weight, in this case, depending on how many credits the class was worth. So one more page. And again, let me make it larger. So we're going to take a look at the effects of skewness, which is how spread out or how symmetrical a distribution is. Skewed data are asymmetrical. So if you remember, our normal distribution is symmetrical. So this first one is normal. Okay. The mean, median, and mode are all at the same point. So in a normal distribution, all of these mean, median, and mode are together, okay, or at least very similar to each other. If it's a perfectly normal distribution, they will all be exactly the same. A set of data or distribution that is skewed to the right, a positive skew, has a tail going off to the right side, and negative or left skewed has a tail going off to the left. And if you remember back where we were talking about mean, median, and mode, and we said that one of the drawbacks of using the mean was that it could be affected by outliers, which are unusual values. Outliers are what's making this tail. And in the case of left, you might have outliers over here. So they're unusual values in the distribution, and they pull the mean in that direction. So and are skewed to the right, the mean gets pulled to the right. If it's skewed to the left, the mean gets pulled to the left. So those unusual values have a bigger impact on the mean than they do on either of the other values. You can see the median is also a little bit affected, but not as much as the mean. So the median in both cases is slightly pulled away from the mode, and the mode is always where the most values are. So if we want to write something down at the bottom of the page here, it's always important to check the distribution before you begin any statistical analysis. That's something that we'll learn about as we do each statistical test. We're going to always check to make sure we have a normal distribution. So that means the mean is reliable. So the one that's most sensitive to outliers is the mean. Okay. And the mean gets pulled to the direction where the outliers are. So if we were to go back and look at the mean, median, and mode for the change in weight, the kilograms calculations that we did earlier, those three, the mode is typically the least reliable. This is kind of separate from what we were just talking about. Just because the mode is simply the most common number in your data set, it doesn't necessarily have to be in the middle or the center. So it's not always a good indication of something meaningful about your data. The mean, we're going to use the most in statistical tests, so we'll use it the most frequently. And we just have to remember to check for a normal distribution before we rely too much on the mean. But again, it is the one that we're going to be using the most. The median is the middle by counting. So sometimes it's close to the mean, but it doesn't always have to be. Again, the median, the mean is what we're going to use most often in all of our statistical tests, and that's the one you should just get used to reporting that for everything. That is the end of measures of center. The next video will be measures of variation, which will tell about how spread out your data is. So these three, mean, median, and mode, I'll tell you approximately where the middle of the data is, and then we'll be looking at variation or how spread out it is next.